Okay, chemistry peeps. We're going to discuss how to balance a redox reaction, an oxidation reduction reaction in a basic solution. So last lesson we went over how to balance it in an acidic solution. And so today we're going to talk about the oxidation reduction reactions that occur in a basic solution and how to balance those equations using the half reaction method. But just like the last lesson, if you don't know how to assign oxidation states yet, you need to know how to do that before you try to balance a redox reaction in an acidic or basic solution. And you want to familiarize yourself with the half reaction method of balancing. All right, so again, the two handouts you should look at are rules for assigning oxidation states. You need to know how to do that, and then also the steps for balancing redox reactions. These are the steps for an acidic solution, and then these are the steps for a basic solution. So these are the steps we're going to be following for today's lesson: how to balance a redox reaction in a basic solution. And essentially, it's the same steps that you would do in an acidic solution, and then at the end, you have to do this final step, which I'll show you in this video. Okay? All right, so let's get to it. So our task is to balance this equation, this reaction that's taking place in a basic solution. And so this is solid, but the ions are aqueous. Remember, these reactions are reactions that take place in aqueous solution. So if aqueous isn't written, it's kind of understood that this would be aqueous, and especially if you have a free ion. Most of the time, you wouldn't have a free ion floating around as a gas. It's usually in an aqueous system, so surrounded by water molecules. All right. So, and a lot of times, especially in AP chemistry, when we're dealing with solutions, if the state of matter is not written, it's understood that it's aqueous. So aqueous, aqueous, aqueous. And we wrote solid here to show you that, oh, okay, we got to precipitate. Okay. All right, so in a basic solution, what's going on? Well, instead of an excess of H+, you really have an excess of OH-, but we'll talk about when that's going to come into play later. It's going to come into play at the very last step. Okay, so remembering that it's OH- and not H+. Okay, but then again, aqueous, so we got a bunch of H2Os floating around. So a lot of water molecules. All right. So here's the deal. We're going to follow the same steps we did for an acidic solution, and then at the very end, we're going to polish it up with hydroxide. All right, so remember what our first step was to assign oxidation states. So here's our oxidation reduction reaction. Let's assign oxidation states to everything in the reaction. Okay. So I circled them here. So in permanganate, the oxygen's -2, and that means the manganese is +7. Bromide ion, that's an easy one. It's 1-, so that's its oxidation number, -1. Now in manganese oxide, the oxygen is -2 and the manganese is +4 now. And then in the bromate ion, the oxygen is -2, but the bromine is +5. So the oxygen stayed the same, but if we look at the manganese went from +7 to +4, and the bromide went from -1 to +5. So manganese got reduced, +7 to +4, and bromide got oxidized, -1 to +5. Okay, so manganese is undergoing reduction, and bromine is undergoing oxidation. But remember, if I ask for the reducing agent or the oxidizing agent, that's opposite. So manganese is reduced, so manganese is the oxidizing agent. Bromine is being oxidized, so bromine is the reducing agent. Okay, just watch out for that. Agent means opposite, all right? So after we assign oxidation numbers, we write our half reactions. So our oxidation half reaction is going to be bromide yields bromate, and our reduction half reaction is going to be permanganate yields manganese oxide, okay? Because this is what got reduced, the manganese, and the bromide got oxidized. So if we split up our half reactions, our oxidation half reaction is going to be bromide yields bromate, and our reduction half reaction is going to be permanganate yields manganese oxide. Okay? So now we follow our normal steps as if we were in an acidic solution. So remember, step 1, balance everything that's not oxygen or hydrogen. Step 2, balance the oxygen by adding water. Step 3, balance the hydrogen by adding H+. And then step 4, balance the charge by adding electrons. So let's look at the oxidation half first. Okay. The bromine is already balanced. We have one bromine, so we're good. So once we settle that up, we can skip to the oxygen. So 3 oxygens, so I have to add 3 water molecules over here. Okay. So that those three water molecules give me 3 oxygens. And so that balances the oxygen. Now we balance the hydrogen by adding H+. Okay. Now remember, you might be thinking, well, why are we doing H+ when it's hydroxide, because it's a basic solution? Remember, we're going to take care of the hydroxide at the very end. So right now we're going to just treat it just like we would in an acidic solution. So now everything's balanced except for charge. And remember, this was an oxidation half reaction. So I should be expecting to put electrons on this side of the equation because oxidation always produces electrons. Okay. So if we look at this, the overall charge on this side is -1, and the overall charge on this side is +5, 6 plus and a -1. So we have to add 6 electrons to bring this side down to match the -1 on that side. So we add 6 electrons. And so this right here, this is our balanced oxidation half reaction. All right. So now let's go to the reduction half reaction. Okay. So we got to make sure the manganese is balanced, and the manganese is balanced. We had 1 over here and 1 over here. Now we balance the oxygen by adding water. 4 oxygens. I have to. Whoops. Oh yeah. Sorry. I thought I messed up there. 4 oxygens on this side. 2 oxygens here, so we had to add 2 more waters to get a total of 4 oxygen on that side. Okay. So now we balance the oxygen by adding water. So now we have 4 oxygens, 4 oxygens. Now we balance the hydrogen by adding H+. So putting those 2 waters there, I added 4 hydrogens to this side. So I have to add 4 hydrogens to that side. Okay. Now we balance the charge. Now remember, this was the reduction half reaction. So we should be expecting to put electrons on this side of the equation, not on this side, because reduction requires electrons. So this side is a total of +3. Okay, 4 plus and a -1. And this side is a total of 0. Everything's neutral. So we have to add 3 electrons. So if we add 3 electrons to this side adds up to 0, and this side adds up to 0 in terms of charge. All right, so this would be our balanced reduction reaction. Now we got to put them together, right? We got the oxidation half and we got the reduction half. We got to put them together. All right. But the problem is we can't add these 2 together to get an overall oxidation reduction reaction. We can only add them if the electrons completely cancel out. And right now, if we added these together, the 6 electrons on this side would not cancel out, would not be completely canceled out because we only have 3 electrons on this side. So what do we have to do? We have to get both equations that have the same number of electrons. And so what we have to do in this case, we have to double the reduction half reaction. That means we have to double all of the coefficients in the the reduction half reaction. Because if we double that, that'll be 6 electrons, and then that 6 electrons and electrons will cancel out. Okay? But let's say this was 3 and this was 2. If this was 3 electrons and that was 2 electrons, we would have to triple this equation, and we would have to double that equation. You have to make sure the number of electrons are equal, right? Okay. So before we add, now this is a balanced oxidation half reaction, and this is a completely balanced reduction reaction. But to combine the 2, the electrons must cancel. So we got to double this equation, all right? So we double that equation, and then we add. So the 6 electrons cancel out. This was 4 H pluses, but now it's 8 H pluses because we doubled everything. So 8 H pluses on this side, 6 H pluses on this side. This 6 H plus completely cancels, and the 8 goes down to 2, all right? Now we have 2 permanganate ions and 2 manganese oxides, but we have now 4 waters here, and we had 3 waters here, so the 3 waters on this side completely cancel out, and this 4 comes down to a 1. And then we write down what we have left over, right? So 2 H pluses plus a bromide ion plus 2 permanganates yields a bromate ion plus 2 manganese oxides plus a water. So this is a balanced oxidation reduction reaction, but we got to pump the brakes. This would be the reaction if you were told that it reacted in an acidic solution, but it doesn't react in an acidic solution, it reacts in a basic solution. So again, if it was the same exact equation and you were told, hey, this happens in an acidic solution, this would be your final product. This would be your balanced reaction, okay? But it was a basic solution. So now what do we got to do? Now we got to get rid of the H plus. Instead of H plus, we got to think OH minus. So how do we get rid of H plus? We add OH minus. Okay, so to get rid of the H plus in this reaction, we have to add 2 hydroxides. But we have to do it to each side of the equation to keep it balanced. So I'm going to add 2 hydroxides to this side of the equation and 2 hydroxides to this side of the equation. Okay, so the 2 hydroxides on this side and 2 hydroxides on that side. Now, the hydroxide and the H plus on the same side will make water. So 2 hydroxides and 2 H pluses will make 2 water molecules. Okay. And now notice we had 2 water molecules on this side and 1 water molecule on that side. So now let's simplify it, and let's cancel out one of these water molecules with that water molecule. And then we'll write down what's left over. So we got H2O plus bromide yields 2 permanganates, plus 2 permanganates yields bromate plus 2 manganese oxides plus 2 hydroxides. And there we go. That is the balanced redox reaction in a basic solution. Okay? All right, so hopefully you found that helpful, and hopefully you feel comfortable in your practice. But it just takes practice, and you just got to get really good at assigning oxidation numbers. So follow those rules, read the notes, do the practice, and you should be in good shape. All right, don't forget to smash the like button and subscribe, okay? And watch the pin video. And have a great day.